Hello, everyone, and welcome to our new webinar, Powering Data Centers of the Future, why Immersion Cooling is the answer for hyperscalers. Today with us, joining one of our esteemed partners and customers, Wyoming Hyperscale White Box, will be digging into the reasons why Immersion Cooling has been selected as the prime technology for future facilities being built out in Wyoming. And with me today, Trenton. Trenton, please feel free to introduce yourself.
Sure. So my name is Trenton Thornock. I'm the founder of Wyoming Hyperscale, and I'm leading this project along with some of my family members. So we're here to talk about the challenges that we faced in figuring out the design for this project and why we're using immersion cooling from Submer.
Hyperscale White Box. I think maybe if you can get us to move to slide 3 and guide us through the mission.
Sure. So we basically have 3 parts to our mission here. We want to be innovative, sustainable, and cost efficient. It seems like the space has been dominated by too much capital chasing too few deals, which has prevented it from becoming really efficient. And that's one of our aims with this project, is to be capital efficient, particularly since we're investing on our own property. The second thing is to implement best-in-class solutions across the business, and that includes things like the Internet of Things, different APIs that will collect information from data center operations. And thirdly, and I think most importantly, our goal here is to impact climate change directly by the way that we design the data center and eliminate the waste, particularly in the power consumption and water consumption areas that are inherent in current data center designs.
And Trenton, just to give us a bit of, I guess, the scale of this project, can you tell us, I know we're going to get into the details in a while, but can you give us a bit of the top figures regarding the data center capacity and size of what you guys are going to build?
Sure. So with phase 1 of the project, we're looking at 30 megawatts. We have phase 2 on the drawing board at an additional 90 megawatts for a total of 120 megawatts. And our engineering services agreement with Pacific Corp, which is the grid operator, will bring us primary power of 120 megawatts to the site. And in addition to that, our family has over 4,000 acres in this area. So we do have plenty of room to do additional development.
So those are true hyperscale figures there for sure.
Yes, yes. I don't think we have yet enough renewable energy to fill up 4,000 acres, but that's a future possibility.
Absolutely. So let's talk a little bit about the challenge, I guess, that hyperscalers have. And one of the reasons why Wyoming Hyperscale White Box has selected immersion as the way forward to future-proof the facility. If you can move us to the next slide. Tell us a little bit about the challenges that you primarily see.
Yeah, so the first thing, it could have been coming across as a little bit cheeky is that there's a big ESG fad in investment, and our feeling is a lot of this doesn't directly impact climate change. A lot of it is lip service, and the calculations sometimes can be somewhat suspect. The second thing is that I live in the Sun Belt and in an area where data center development is becoming concentrated. It's also becoming concentrated around the Washington, D.C. area, which we think is a national security risk as well. And based on climate, we don't think that this area is ideal for data centers going forward. One of the reasons is the high cost of cooling when you have something that's generating a lot of heat and you put it in a hot area, you're just compounding the issue on a metro basis. The next piece is tropical event exposure, and we've seen in the last year that sometimes we get hurricanes that come up from the Gulf of Mexico, and they basically can impact almost the entire midsection and even the east coast of the country, depending on their track. The last thing we have here is negative industrial impact, and one of the things that ESG is causing is loss of jobs in the oil and gas space. And the area where we're building our project has been an oil producing area since the late 1800s. I have a map on my wall from the Standard Oil Company in 1903 with all of the rig locations that were there. And so we've got a situation where the local community and the local government are hurting because those jobs are going away and they need a replacement in terms of both tax revenue and higher paying jobs.
Absolutely. Okay, I mean, one of the challenges that we don't get tired of talking about is obviously how PUEs have stalled in the last few years. It's quite obvious that so this is a report, the latest report from the Uptime Institute, stating what Uptime Institute certified data centers have reported as a medium PUE. And it's quite obvious that the innovation is not bringing that number down anymore with the traditional technologies. And so we truly believe that it's the end of the story for air cooling when it comes to really looking at achieving the next level of efficiency. Liquid cooling technologies will need to take over and really enable that next unprecedented, I guess, 1 or below 1 PUE figure that we're really trying to position in the market. The next slide, what it shows us is the latest, an image from the latest ASHRAE report, specifically the one related to emergence and expansion of liquid cooling in mainstream data centers, where I know your team has been very active actually in putting together that document, right, Trenton, in supporting it?
Yes, John Gross, who is our Uptime Institute accredited tier designer, is one of the authors of this paper.
Yeah. And resuming, what we can see here is how it's end of life for air cooling as soon as you start getting into the range of anything above 200 watts on the chip side. This year, I know we'll be seeing the first 300 and 350 watt CPU being released, and obviously that already puts us at the very end of life for air cooling. I guess this is one of the main reasons why we set out to develop immersion cooling. It was obvious that at some stage this was going to occur, like we've seen in other industries, I guess, where you have power electronics, or for example, in vehicles, where over the automobile industry, over the period of maybe a decade, we saw all vehicles transition from air-cooled engines to liquid-cooled engines. I guess we're going to see something similar in the data center industry over the next decade, as those facilities that were today still being built with air will most probably not be future-proof and won't be able to support these higher end densities, 400 and above, without substantial increase in the power consumption and a deteriorating PUE. some interesting figures on the next slide around the specifics of this project, I guess, for the 30 megawatt phase one that you were referring to, Trenton. Some of the numbers so these are savings or the dimensions for the 30 megawatts. So for example, I can see here 5,000 square feet of space for a 30 megawatt facility. How would that compare typically to a traditional build, Trenton?
So this is just the compute space and doesn't include all of the space that's required around the compute space to navigate. So the savings is actually going to be larger than this. So when we originally started this project, our assumption was that we would need at least a 350,000 square foot building, along with all of the backup generation and warehouse and network operations center. That has already shrunk by more than a third. And I think by the time the final design is polished off, it will actually be smaller than that. So we're seeing significant savings based on our selection of cooling technologies.
Yeah, we're quite familiar with some of the 100 megawatt facilities out there, and they tend to be in the range of the 800 to 1 million square feet. So right. That's a good reference there. Obviously, the savings on water, given the type of technology being leveraged, which we'll dig into a little bit later on. But also, what has your assessment been on the construction cost of traditional build out versus immersion as you've analyzed that?
Yeah, so at this point, a lot of the data center buildings have been tilt-up concrete. And while that's efficient compared to traditional construction, what we're able to do here is use a concrete slab with a metal building. And that does two things. It makes the building much less expensive, and it also allows us to construct the building in a much shorter period of time. So the type of metal building that we're looking at, we think will take less than a year to construct.
Yeah, okay. Which obviously translates directly into lower construction costs.
Yes, much lower.
Okay, and the product that you'll be leveraging inside of that facility is actually the SmartPod XL Plus, one of our flagship immersion tanks, which is designed for up to 100 kilowatts of heat dissipation with warm water loops. These immersion tanks, as a lot of our attendees that typically join these webinars already know, are designed for 45Us and 22U form factors. But most specifically, what's interesting is that they leverage 19-inch and 21-inch OCP standards simultaneously. So we can configure these tanks to support both of those standards. And they're compatible with a wide range of hardware vendors. Now, Trenton, for the infrastructure that you'll be running, the compute infrastructure that you'll be running at Wyoming Hyperscale White Box, are you looking at open compute as one of the potential standards that you'd like to leverage for the IT side of things?
Yes, in fact, our tier designer is an active participant in setting those standards, and some of them haven't even been released yet. So the approach that we're taking in the design phase is, we know the weight of the pods, and that allows us to complete our building design. And then to the extent that we need to tweak connection sizes and types and do other sorts of tweaks based on the guidance that comes out from OCP, we can do that. And our overarching goal is to have the first OCP ready liquid cooled data center. And just so happens that our go live date corresponds to the 10th anniversary of the creation of OCP.
Oh, wow. And I guess we'll be also looking at OCP v3 standards given the timing, because we're right there on the verge of seeing a lot of those already being implemented very soon.
Right.
So we'll definitely expect to deliver these tanks with OCP version 3 configurations and those 48-volt bus bars that bring additional efficiency and density. It's thanks to the 48-volt bus bars that it's going to be super easy to achieve 100 and 200 kilowatts even in one of these immersion tanks. So exciting times for immersion cooling as systems get designed for the right density, where immersion obviously has a super aggressive TCO.
That's correct, and we've been very pleased with the flexibility of your engineering team and working with our tier designer to ensure that we get to the right place by the time we're ready to go live.
Awesome. So on the next slide, what we have are the typical benefits that we see in immersion. So obviously the humongous reduction in the cooling OpEx, which comes primarily from just the simplicity of the end-to-end installation on the cooling loop. The less components, and those components just leverage in dry cooling infrastructure for the secondary cooling loops, but then the efficiency of just transmitting heat from liquid to liquid and no air being involved obviously drops the cooling cost substantially. Something that's not, like when we refer to the PUEs that we can typically achieve with immersion, what's quite hard to wrap your head around is that a big percentage of the savings actually come from the removal of fans, especially in the higher density hyperscale type of hardware, which is running usually in very warm data hall temperatures to try and gain efficiencies in the system. What we've seen is that with the typical OCP nodes, we tend to drop the power consumption between 10 to 15% on the higher end systems just by removing the fans. So there's a humongous drop on what today is compute power, but it's obviously in some way related to cooling, given that it's essentially fans spinning inside of the servers. Something which is super interesting also with immersion is how the hardware failure rate massively drops thanks to much less, well, actually zero moving parts inside of the systems, but also the non-existence of dust particles and electrically charged particles that you would typically encounter in a data center being blown through the IT hardware at very high speeds. That's something that doesn't exist in the pristine environment of immersion cooling. And so we see that the operations teams will manipulate the servers just a fraction of what you would need to interact with them in air-based environments. On the next slide, maybe you can give us a bit of insights into the specifics around the extreme weather conditions and the earthquake situation at which you're exposed in Wyoming. I think it would be very interesting to understand some of the challenges that you've detected and how you see immersion benefiting those.
Sure. So we'll start with the smart coolant, and in our view, we love the pod design, but really what's I think the marketing folks would refer to as the category killer is the smart cooler. As we'll see in a couple of slides, it's very safe. From what I understand, it's basically food grade. I wouldn't recommend drinking it, but I think you could and not be harmed significantly. And moving to the next slide, while we're on the edge of the Wasatch Front, which does have a lot of earthquake activity, Basically, what we were able to do is when we shrank the building footprint and changed the design, that freed a lot of capital. And so as we went down the checklist for hyperscale data centers and looked at all of the potential risks, the one that we couldn't check the box on was earthquakes. And it just so happens that the 4,000 pound per pod weight gives us enough weight that we can engineer a greenfield seismically isolated slab for this data center. And that basically allows us to check that last box and still have a lower construction cost. In terms of the extreme weather conditions, we are in a very cold area. I was in the area during the freeze down here in Houston where everything shut down. Most of the infrastructure in that area is engineered to operate at a very low operating temperature. So this area has extreme weather a lot, and none of the power shut down. All the windmills kept turning. All the wind power was on, and it actually turns out being a net positive because we have very robust infrastructure, and the folks that are used to doing maintenance on these types of assets are also used to the extreme weather conditions. The last thing here on the slide is net zero water and heat reuse, and I think this is the one where we're not going to go into too much detail on how, but at this point in time, this area, along with good chunks of California and a lot of the West, is under a drought. And the last thing we wanted to do as a neighbor was to go and permit a new water treatment facility that would suck down millions of gallons of water. And so our architecture specifically allows us to avoid water consumption. And based on some of the design elements that John Gross is bringing into our cooling loop, it will also allow us to offtake that heat for other purposes.
Right. Thank you. So now I think, Trenton, we definitely like to understand a little bit more about the project, who's behind it. So please take it on.
Sure. So that's easy. My family have been in this area since 1869-ish, and depending on which side of the family we're talking about. So my partner in the venture is my brother. He's also the operating partner for my parents' land holding company, which is GNC Holdings. So among us, we are behind the project. At this point, we're supplying all of the capital, and it's actually been a pleasant experience working with my brother. I know some folks have trouble working with family members in a business, and so it's been really nice. And moving along to the project, as I mentioned, there's a patent pending closed loop cooling system. And what we're trying to do there is not just decrease the exploitation of nature, but accentuate the natural site attributes in this area. One of the ways that we would like to do that, and that will depend on the exact customer mix that comes into the facility, is to use AI-driven workload management systems in order to optimize the amount of power consumption in the data center. And finally, this area is surrounded by 4 large-scale wind farms, and we also have a large-scale solar farm, which is only a mile or 2 beyond where my brother lives. All of this stuff is connected to the Berkshire Hathaway Pacific Corp, and locally it's known as Rocky Mountain Power Grid. And the grid owner actually owns 2 of those large-scale wind farms. So they have an I guess, an indirect stake in this project becoming successful, which is helpful. Speaking about the climate in this area, we're in a very cool area, and our temperature records come from the nearest city, which is a couple of miles away. We think that we're actually cooler than this. We're very sequestered. As I mentioned, there's a lot of acreage. I think inside the fence line, including land that we lease from the Bureau of Land Management and the state of Wyoming, we're basically in a 12,000 acre piece of property. So just using the private sections and existing easements and rights of way for access, we're able to place this facility in an area that is very difficult to get to without the private access. And we think that's a definite benefit for our customers. It's not in a metro area. And the last one, we've mentioned a lot of these things before, but excuse me, what I'd like to do is focus on a couple of the things that we found last week while we were touring the site with our engineers. And that is that we're going to be able to offer a lot of diversity to our customers because of the, I guess, a happy coincidence of history. We have several networks that run through the area. So we not only have diversity of carriers, we have diversity of routes, we have diversity of networks, and we've also located dark fiber that goes to strategic telco hotels. So I've been asked a couple of times how I selected this site to have all of those attributes, and the bottom line is it's serendipity. It was a fortunate accident. Talking about the market opportunity here, these numbers can probably be argued. They always are in strategic discussions, but we're dealing with a very large market. The market we know has been driven by the COVID-19 situation over the last year, and our view is that that transformation will continue. Our project build cost is around $180 million. We're doing what we can to value engineer that number down. Part of the reason why our total cost of operation is low is that we already own the property, so there was no acquisition cost. And the last bullet there is just so that the private equity folks that I've dealt with over the last 10 years who check our sources and uses will understand that we have the value of a right of use asset in there that gets us to a little bit larger number than the 180 million. This slide shows that Evanston is about 9.8 degrees cooler than Prineville. That's another, I guess, kind of rural location where Apple and Facebook have invested more than $2 billion. So this is the temperature data for Evanston, Wyoming. You notice that overnight it cools off quite a bit, which is similar to what we see in Prineville. But going back to Evanston, you see the temperature extremes on the low side are a little bit lower, and the highs are a little bit lower. So we have a very favorable weather situation in order to take advantage of the local microclimate. As I already mentioned, we have just over 400 megawatts of green power in the area. We're also on an export constrained grid. In other words, the offtake capacity is not yet there to move all of this electricity to other markets. And so what we've observed, my brother specifically, because he spends a lot of time out here, is that a lot of times when the wind is blowing, the turbines on the wind power farms are not turning. And we've been able to ascertain through conversations with various folks that we've got a capacity constraint situation where we're going to be adding a load to a grid that needs that load. This is another little map of the transmission network in the area. Down here in Texas, go ahead.
No, so Trenton, the turbines are turned off because there's no consumers for that energy, essentially, then.
Yes, yes, and that's the case in a lot of places, and it's also due to storage issues, which I know a lot of folks are working on.
Yeah.
The reason why we put this slide in here is it shows that the Bridger West plant, which is actually a large steam plant, provides the base load for this area. So it's weather hardened. It operates, sometimes down to 40 degrees below zero. So we don't have issues like we saw here in Texas this spring, where we have unusual cold snaps that shut down the power grid.
Okay, thanks. And maybe let's dig a little bit into the immersion technology itself. These are slides that I show again and again. I think we'll walk through them quickly, but we'll focus on a couple of them to make sure that we're all on the same page. Here regarding, I guess, the typical layout for immersion, so how it's built into white space. I guess from what I've heard, Trenton, your team is really looking at optimizing some of the things on the secondary cooling loop from a design perspective, and also from an AI and orchestration perspective as to when and how those loops are leveraged. I think for the region, what's super interesting is, for example, the dielectric fluid that we use is not, doesn't freeze. Actually, it can support up to -40 Fahrenheit without freezing, interestingly enough. And we're starting to see the first implementations also of immersion fluid being directly taken out to the dry cooling infrastructure. So there's some additional benefits down the road of potentially eliminating a heat exchange, which is occurring inside of the tank in our specific case, with the CDUs transferring the heat from immersion to water. But there's still a lot of R&D and possibilities that need to be explored around leveraging the dielectric fluids directly out to the dry cooling infrastructure, which we're super excited about, and definitely we'll be talking about more and more.
Yes, and in our case, part of the secret sauce is how we dispense with the dry cooler, because even though in adiabatic coolers, the water consumption is cut versus the traditional cooling towers, there's still water consumption. And so what we've been able to do is remove this piece entirely, and that saves us roughly $6 million in capital cost. Yeah. There is an offset, of course, nothing comes for free, but basically it allows to create a data center infrastructure that is essentially silent. So we have no fans because of what the Submer pods inside the data center. So we have no rushing air, and also on the outside, since there is no adiabatic cooler, we have no fans outside either.
Yeah, and then I guess the zero noise in the data hall. I don't know if anyone here in the webinar or listening to this session has been in a hyperscale facility, but they are super noisy, and typically it's really hard to stay in those spaces for more than 15 or 20 minutes without your ears really hurting. So having an environment which is completely silent is super strange to our customers when they start with this technology. Being able to just stay in a data hall like it's a meeting room is quite peculiar.
Yes, I had several conversations with various engineers of various types last week, and I heard the term "I'm geeking out" from more than one individual. So it's a novel configuration. It's the nice thing is that we're not doing really anything new here. It's a new configuration, but we're configuring existing technologies. They're proven, and there's no reason why the entire industry shouldn't go this direction going forward.
Yeah, and it's just one of the nice side benefits, I guess, of immersion, the silent space. But for those of us that have worked in data centers for quite a few years, it's going to be a game changer for sure.
Yes, I was previously in the environmental services business, and we have some of the same OSHA issues doing tank cleaning down here on the Gulf Coast, as we now have emerging in data centers where it's so hot that the workers have to take breaks every 30 minutes. And based on our architecture, the noise goes away, the hot aisles go away, and we end up with this silent data center with much higher compute density and lower cost.
So talking about that, on our next slide, we have the typical image that we love to represent, which really shows the density comparison of a 2 megawatt data hall based on 10 kilowatt racks, which is, it's quite normal to see today. Pretty common hot aisle, cold aisle layout with crack units. Those crack units can be mechanical rooms or not, but that still seems to be the traditional build versus high density 100 kilowatt immersion tanks and the space that they require. During your design process, has this level of density been validated? Is it like what you're speccing to, Trenton?
Yeah, so we're speccing to 80 kW per pod. We know that it can go up to up to 100, but what we're saying is we know that the actual content of the pods are going to vary a little bit, and so we're working to an average density of 80 kW. We know that some pods that are just full of straight compute will be at 100. And the way our data hall design is working out is essentially we're going to have 4 data halls that are essentially the same. So it'll kind of look like this, but smaller. And space-wise, what we've been able to determine is we can do 4 7.5 megawatt data halls, and those will take up, including all the floor space and the space for gear, about 11,000 square foot per piece or per data hall. So it's significantly smaller than what one would expect in a normal, like I say, a traditional data hall.
Yeah, absolutely. Okay, and then maybe quickly about the smart coolant, which is on our next slide. I'll go through the main key properties. The 15-year lifespan, which is what it's designed for, and this is based on the fluid temperatures at which we typically operate the systems in the data center space. So accelerated testing, we've had installations already running for nearly 5 years with this fluid, and we have no reasons to think that those won't make it to the 15-year lifespan, but accelerated testing has proven that these fluids are more than capable of lasting multiple iterations of IT hardware and most probably the full lifespan of the data center as well. The fluids are, of course, non-corrosive. They don't oxidate, and most interestingly, there's 0 evaporation rate. So there's no topping up of these fluids. They are designed as a non-consumable product. So really, it's just part of the cooling infrastructure built into the immersion tanks, of course. The natural barrier against dust and moisture, as mentioned, super interesting for some challenging regions that we've recently been engaging with that have, for example, sulfur in the air. There's some regions on the planet that really have challenges with the air quality. And of course, the traditional data center designs, it's very complex for them to implement that direct air free cooling when the environment is pretty harsh. But even when it's not, and you're comparing to a traditional clean data hall, what you tend to encounter is that hardware failure rates are tied into microparticles, dust, and electrically charged particles being shot directly onto the IT hardware at high speeds, causing hardware failures. In immersion cooling, what you essentially have is a medium, a protective medium that is avoiding any type of dust and particles in or around the servers, and so just causing that 60% reduction in hardware failure rate, together with the no moving parts. And most importantly for us here at Submer, when we refer to 8 times safer, what we mean is that it's actually 8 times less conductive than air. So the immersion fluid is 8 times less conductive than air, even though when you look at a server in a liquid, the first thing is to freak out. It's quite fun to see at events. Hopefully we'll get back to those very soon. But when people that have never seen immersion see it for the first time, it looks like black magic to them, and the expressions on their face are great sometimes. And most importantly here at Submer, what's really important for us, and it's one of our main competitive advantages with our fluid compared to other fluids out there in the industry, is that we designed it from the bottom up to be biodegradable and non-toxic. Just because a lot of in a 15-year lifespan, God knows what will happen to the fluid. We might not have control over its end of life. And of course, we want to make sure that even if disposed of incorrectly, it's not going to be harmful to our environment and our planet. Obviously, no mention. I mean, it's obvious that it's a non-flammable fluid. These fluids are designed to be extremely safe in the environment that they're going to be operating in. And we have other videos out there with our chemical engineers using a blowtorch directly on the system to prove that it's obviously non-flammable. Moving forward, I think we've mentioned all these points already in the presentation. Obviously, I would emphasize on this is one of the first technologies that really captures 99% of the heat in a liquid. And by doing that, it opens the door to energy monetization with what used to be up until now just waste heat that we needed to get rid of as quickly as possible. Now we still can, of course, get rid of it as quickly as possible for a fraction of the cost. But on top of that, we've opened the door to monetizing that energy in different ways. And we have customers that are doing that, be it by supplying the heat to district heating systems today, be it through symbiotic type of agreements with neighbors, facilities in the vicinity of the data center that can leverage that heat in their industrial or business, commercial processes, business park, industrial park, etc. And down the road, we envision even more exciting possibilities for this energy as the return temperatures from our immersion tanks go higher and higher through hardware that's specifically designed for immersion. So yeah, some exciting stuff coming there. And then I guess to close, maybe if you could guide us through a specific use case regarding the using heat to power the local ecosystem, which I think connects directly into what I was just referring to.
Yeah, so in our case, we don't have a district to heat because we're a little bit rural and we have no close neighbors who can use this heat. So we've been looking at different options outside heating our common spaces outside of the compute area. So we'll use the heat to make sure that our network operations center and non-data hall spaces, including our backup power generation area, are all comfortable since we're in a pretty cold environment. One of the other things that we've looked into extensively is greenhouses and vertical farms. Most of the produce in this area is shipped in from California, which is thousands of miles away. So we have no local production of produce because of the weather and the climate in the area, and we can actually change the climate with vertical farms and greenhouses to be able to produce that kind of stuff. And of course, that's our family's main business, and so we'd like to see as much agricultural connection as possible. And through some of my former contacts in the energy industry, we've also looked at things like carbon capture and plastics recycling that can use the waste heat that we're going to generate. So probably what you're going to see is in phase one, which is 30 megawatts, we'll not focus on this as much, but when we get to the 90 megawatt expansion, we'll certainly want to start off taking some of the waste heat and driving our PUE below 1.
Absolutely. Okay, well, let's move into Q&A. We have some questions from the attendees, so I'll read the first one from Jerome Van Bemmel. You mentioned Berkshire Hathaway. To what extent are you actively cooperating, coordinating with the power grid operator, and do you see opportunities to do more?
Yes, I can only tell you what we have, and what we have right now is an engineering services agreement with Rocky Mountain Power, which is part of Pacific Corp and Berkshire Hathaway Energy, to bring 120 megawatts of primary power to the site. We expect that that relationship will develop over time, and we'll be back in touch and on Twitter as things evolve.
Okay. Another question, and please feel free to add more questions to the chat or the Q&A window. So we have, when will phase one be ready? Will we be able to visit the site?
Well, we were visiting the site last week, so site visits are available now, but there's not much to see except for a 10-acre pad. So on the current timeline, which is subject to review by our tier designer, who's basically acting as our owner's rep with respect to the architect and general contracting part of this project, has us going live in about August of 2022. So it's not far off, and the first thing that will happen is there is some existing infrastructure in the area, so we're not starting from scratch trying to build a brand new node. Some significant CapEx is already in place just by virtue of the fact of where this project is located. So the first thing that will happen is we'll start plowing fiber and to the site from the existing infrastructure, and that will happen in July approximately of this year, which is only about a month out.
So you're breaking ground in July then?
Indeed.
Right. Will you have your own compute? If so, are you going to be leveraging Immersion for your own compute? I guess that's an obvious one, no?
Yeah, so the answer is yes, and the way that the project is modeled right now has us owning and operating all of the compute. Now, to the extent that the customers want to come in and bring their own equipment, it will need to be immersion ready, but otherwise there are no restrictions. And the whole idea here is to have an OCP ready data center.
Yeah, so that actually connects with another question that I see here. So give me a second, let me pull it up. It says, what is a high-level strategy to attract immersion tenants? Do you see enough traction already in the early stages of the technology to build 100% immersion? And I guess, so you just mentioned that primarily you're building to run your own compute in this facility. So these 30 megawatts are potentially to run your own compute. But you have mentioned that the possibility of accepting other tenants into the facility. Can you maybe give us a bit of an insight there?
Yeah, this industry is the only one that I've been involved with that is more secretive and papered with NDAs than the oil field services and drilling business that I was in for a time. So it's hard for us to talk about this. Everyone knows who the hyperscalers are, and all I can say is that we're having conversations and have had conversations to help us craft the design, and there'll be more on that later.
Right. Thanks, Trenton. Yeah, I understand. It's early times. Okay, we have a question from Helge Stranden. Do you support Mellanox InfiniBand with fiber connections in the liquid? I can answer that one. We've deployed actually quite a few InfiniBand systems into immersion, given that supercomputing was kind of the first areas where we were deploying the technology. So I can say yes, we have. And the connections in the liquid, yes, also we have. Depending on the type of connectivity, it can be directly done, or some minor workarounds need to be implemented. What is also exciting is that companies like Mellanox, or in this case NVIDIA and many others, already also have a roadmap for immersion. So products are evolving in the direction, primarily for the reason that we were talking about at the very beginning of this webinar, where the future chips will only be able to cool them through liquid cooling or immersion. So absolutely every OEM, ODM, you name it out there today has a plan and a roadmap around immersion. And if they don't, it won't take them too long to be in that position, given that it's quite obvious that it's the direction that things are coming. Here at Submer, we've been preaching in the desert for quite a few years. But it's obvious that finally some of these humongous oil tankers, these large server manufacturers and silicon manufacturers have gotten to a point where they believe that it also makes sense. So exciting times ahead for sure. And I think we have time for one more question. Just checking here. So actually, there's no more questions. We've answered them all. So I guess that with that, anyway, if anybody has any questions after the session, or if you view this online and it's not, it's recorded, feel free to shoot us an email. You can always reach out to us over our socials. Please join us on LinkedIn, YouTube, you name it. We're on every single social network out there. And Trenton, thank you so much for your time today, for joining us. We're looking forward to seeing the completion of that phase one and supporting with that project. And I'm sure that when people start to see and be able to visit this 30 megawatt phase one, it's really going to help the immersion industry to go to the next level. So really appreciate your support. And I think we'll have you back in a few months' time once that first phase is nearly finished, and we can maybe talk a little bit more.
It sounds like a great plan. And by the same token, Daniel, thank you for your partnership and for Submer's flexibility in helping us with our design and ensuring that we're headed toward OCP ready. We appreciate that.
Thank you, everybody, and stay safe. See you in our next webinar.
Submer. Data centers that make sense.